7. Solving equations in one variable, extraneous solutions. So we're solving equations. I'll be honest, you've seen these types of equations before. Okay. We do have to be on the lookout for extraneous solutions. So solutions that we get that we think are going to work, but then when you check them, they're not going to work. And I have kind of a shortcut for checking. Okay. So let's start with example 1. X plus 3 over x equals 4. Thoughts on where to begin?
Multiply an x out.
Okay.
Multiply both sides by x. I think
Yeah.
you should subtract before.
We don't want a denominator here. Okay. We don't want a denominator, so to get rid of a denominator of x, since it's divided by x, we're going to multiply x. If you multiply one piece of the fraction by x, you have to multiply the whole fraction, or the whole equation by x. So we're multiplying left and right by x. On the left side,
X squared plus 3x.
yeah, you're going to distribute. X times x is x squared. X times 3 over x. An x on top and an x on bottom will cancel. And you'll have plus 3 equals, on the right, 4 times x is 4x. Okay. If it's x squared plus 3 equals 4x, next step is to,
Subtract that 4 over.
okay, because we see a quadratic coming here, don't we? Make your equation equal to 0. So x squared minus 4x plus 3 equals 0. What are solving options here?
X minus 3 and x minus 1.
Okay. We hope it factors,
I do.
and it does factor. So we're going to break it into 2 parentheses. X squared breaks into x times x. Multiplying to be 3. It's 1 times 3. If they multiply to be a positive, same signs. If they add to be negative 4, they're both negatives. Then you're going to
Set equal to 0.
set each factor equal to 0. So x minus 1 equals 0. X minus 3 equals 0.
X equals 1 and 3. Positive.
Okay. Add the 1, add the 3. We get answers of x equals 1 and 3.
That's it. That's all we're done.
Okay?
Actually,
Now-
it's not too bad to plug back in.
Okay. So I'm going to go through some different check options here. Okay, I'm going to go through some different check options with different examples. This is, as Logan just mentioned, an easy one to just plug back in to do your check. And so one option that you have is what I would call an algebraic check. So you can check this algebraically. Now, when we check and we talk about plugging it back in, checking it algebraically, where are you plugging it back into?
The original.
The original. So if we plug it in for x, if I plug in 1, 1 plus 3 over 1 equal to 4. Does 1 plus 3 equal 4?
Yes.
It does.
Yes.
Then if I plug in 3, 3 plus 3 over 3 equals 4, which becomes 3 plus 1 equals 4. Does 3 plus 1 equal 4? It does. Okay. Now, I'll talk about this more later, but the key here is to watch out for anything that would make your denominator equal to 0. My original denominator was just x. The only thing that would cause a problem here is if I plugged in 0, because you can't have a denominator of 0. Okay?
What's the other version? Graphically.
We're going to talk about graphic check for options when that is helpful. Okay? So this is a good just plug it in algebraically, or in all honesty, as long as neither of my answers make the denominator 0, it's probably good. Okay? Example 2. X plus 1 over x minus 4 equals 0.
Multiplied by the conjugate of x minus 4.
No.
Multiply.
We want to get x minus 4 out of the denominator, so multiply by
X plus 4? X
No.
minus 4?
x minus 4.
Why would it? Oh,
We're just trying to get it to
they would-
cancel
yeah,
out the
cancel.
denominator.
Yeah, my bad. Hey,
Okay?
I want to touch it.
So basically, you are looking for whatever your common denominator is. Okay? In this case, my only denominator is x minus 4. So I'm multiplying both sides by x minus 4. On the left, I'm distributing that x minus 4. So in that first place, x minus 4 times x, well, for this moment, I'm going to write it as x times x minus 4. Or if you want to go ahead and multiply x minus 4 and x, you're going to have to
distribute.
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 Plus, what happens when you do x minus 4 times 1 over x minus 4?
Just cancels, and then you get 1.
X minus 4 on top cancels with x minus 4 on bottom, so you have plus 1. 0 times x minus 4?
I'm about to say 0.
That's a 0.
Count that up.
If you haven't already distributed, you need to now. So x times x minus 4 is going to be x squared minus 4x plus 1 equals 0.
Your
What's next?
or
Okay.
just plug it into the calculator.
Does it factor? No, because we don't get a product of 1
It's just like
and a sum of negative 4. So officially, we are talking quadratic formula. So, negative b,
Negative.
so 4 plus or minus the square root, b squared, so negative 4 squared, minus 4 times a, which is 1, times c, which is 1, all over
2 times A.
2a, so 2 times 1.
that's not too bad. So basically, it's 8.
So
minus
4
4.
plus or minus
The square.
negative 4 squared is,
8.
no,
Sorry, 16.
16 minus 4 times 1 times 1.
12.
So 16 minus 1 is the square root of 12 all over 2. What do you know about the square root of 12?
Square root of 4, square root of 3.
Oh, he sauced it up.
So the square root of 12 is 4 times 3. A square root of 4 becomes a
2.
2 out front. Square root of 3 stays
Square root.
under the radical all over 2.
Then dividing side by 2.
Okay. Both pieces divide by 2.
Here.
So-
2 plus or minus square root of 3.
4 divided by 2 is 2. Plus or minus 2 square root of 3 divided by 2 is square root of 3.
Go.
So I now end up with 2 plus or minus the square root of 3. Now, options for checking here.
Graphic. Just graphic.
Okay.
Graphic.
We are going to talk graphic now. And, okay, listen. One option, my brain says these are most likely going to work because the answer that's not going to work is 4 because that's what would make my denominator equal 0. So I'm going to say most likely they're going to work. To do an official check, I am going to suggest that we check graphically. Now, in order to check graphically, a couple of things here. First of all, you're going to graph your original equation as it was equal to 0, which we start off with. So you're going to graph y equals x plus 1 over x minus 4. And then where are the solutions on a graph?
0.
The zeros, the x-intercepts. So then you're going to check your x-intercepts, aka zeros. And that's going to be your check there. Okay. So if I graph x plus 1 over x minus 4, and I graph that. My graph looks like such.
It shall do.
Okay. Well, I'm showing that there's two answers. Now, a couple of options.
Put that 0 by.
Do we know what 2 plus the square root of 3 is and 2 minus the square root of 3 is?
Yeah,
It's about
3.73.
like 3 point something.
Could you find them?
Yeah,
Yeah,
You can.
Got it.
So-
2.
There's a couple of options here that we can do. Is I can go back to my main screen for a moment and find the square root of 3 and 2 minus the square root of 3 and 2 plus the square root of 3. So that is one option that I'm not saying you have to have those, but it is helpful in this checking scenario. .73 and 0.27-ish.
Yep.
Okay.
Yep.
And if I go back to my graph, I can find my zeros by doing second calc and 0. Left, right, and guess. Notice 0.2679492. Was that one of my answers?
Yeah.
That was.
It's
So that checks. You can find your other 0. Left bound, right bound, and 3.7320508.
Why
Okay.
can't we, I mean, couldn't you just technically also graph like the x squared minus 4x plus 1?
That doesn't find you extraneous solutions because you've already altered the original equation. And so I know 3.73 and 0.27 are going to work in x squared minus 4x plus 1 because I used the quadratic formula on that specific equation. We altered the original equation by multiplying it by x minus 4. So, as I said, basically the extraneous solution you would most likely run into here, is, if there was one, would be 4 because that's what would make your denominator equal to 0.
But
Okay.
you still get the same answer. Is like what I'm confused about. Like why we just have to use the original. So like on example 1, would we use the x squared minus 4x plus 3 to graph?
No, you have to go back to the original
But it's,
because you've made changes here.
but it's equal to 4.
So you'd subtract the 4 over
And
it.
then just make it x
Right.
plus.
But anytime you start multiplying by variables, you've made changes that could change your
So
answer.
look at this, right? This is what x squared minus
Yeah.
4x plus 1 looks like.
But it gives you the same answer.
That's true, it might.
It gives you the exact.
And it will. It will. So like if I graph x squared
It does.
minus, and this just gave me an idea of a check option here. Where should it cross through?
Same spot.
The same spots. Is that maybe a quicker check than finding the zeros?
I think that's what you've been saying the whole time.
Yeah.
Okay, well then if that's the case, then okay.
I think
I wasn't understanding that.
Alright.
Okay. So, I thought you were saying graphing that as your original
Oh no.
and not graphing the other one at all. That's where I was
I mean, in
at.
this case it would work, but
You
like.
don't have to graph it.
So. Okay. So those are options. One other option I was going to show is, keep in mind, you can also, remember if you hit trace, you can type in an x value. So I could type in 2 plus square root of 3. And it will tell me that the y value is 0.
How'd you go to type it in?
So if I hit trace,
Yep.
and don't need to move the cursor or anything, just start typing. When I start typing, it pops it up down there.
I gotta re-put the graph back in.
Okay.
Oh wait, you have to click enter after?
After you finish typing 2 plus square root of 3 or 2 minus square root of 3, yes. Now, this is also the same thing. If you go into your second calc menu and you use value, it's the same thing. You can type in an X value and it'll give you the Y value.
Yo, where has this been my whole life? 2 plus 3.
Pretty sure I've mentioned it before, but that doesn't mean you've caught on to it. Doesn't mean that it was important to you at that moment, so it doesn't mean that you caught up on it.
This buffoonery.
Okay. If I continue with example 3, we're gonna get caught in the middle. So tomorrow, we will do examples 3 and 4 in class, and then plan for work time. So bring your book, your iPad, whatever it is, so you can work. Huh?
What's the numbers on the homework, so I can.
If you want to start looking at homework,
I'm gonna start early, but never start.
it's page 227, 4 through 28 evens.
Oh, I bet I'm gonna do that.
Okay? I wasn't sure how much time we'd have for notes, which is why I didn't put the assignment up there. I probably should have put the assignment up there, but
Yeah, we should.